Right, now we're going to talk about how to clear the input string. We've been working with your homework problem on running, creating this program that has all these different functions in it, right? In part 1 tutorial, we displayed the main menu, we wrote the function to fill an array with random values, and we came up with this code that's seen in this file, right? And as you work through and develop your code, right, you want to get all your basic functionality working. You want to get everything working for your best case scenario, meaning you want to go ahead and finish your code for all these other functions that you need to write. But you want to come back to the problem then of what happens when the user gives us bad input, and what could bad input be, right? So if we just go ahead and run this problem here, what we have, we expect the user to enter a choice, right, 1 through 7. We want to take a look at, well, what happens if our user enters a choice of 0? That's not a valid choice, right? Well, the way this works right now, it just comes back and prompts the user to enter another choice, right? Simply because here in main, the way we left it off after the part 1 tutorial was all we were handling is this first case of filling the array with random values. The next thing that happened is that it just comes back and asks us for the menu choice again, right? Simply because we're staying in this while loop until we get quit program, right? Same way, if we hit a 2, we haven't written the code for that. If we enter a 3, we haven't written the code for that. A 4, we haven't handled that case, right? A 5, haven't handled that. A 6, we haven't handled that, but we are handling 7. All right, so it looks like our program is going to at least keep cycling through for all of those choices, and then for other invalid numeric choices as well. So if we were to run this again, right, and I happen to type in 19, well, it just comes back around and prompts me to enter my choice again. That's okay, right, at this point. What we want to do then is consider is what happens if the user doesn't type in a numeric value. Remember, we're trying to read an integer here. What happens if the user types in, the letter R? Now my program is looping over and over again because scanf failed. The R that I typed is still out on the stream, so it's still sitting there in the input stream. It hasn't been removed, and our program is just repeatedly running in this infinite loop. So I'm going to hit Control-C, and we're going to talk about what to do up here. So anytime we use scanf, we're going to talk about what we do if scanf fails. All right, so let's go to here and get menu choice. Here's where we're working with scanf. Right, we could capture scanf's return value. We've done that before. So scanf returns then a value of the number of items it successfully reads. Right. So we're asking scanf to return or to read one argument, right? An integer. If it's successful, it'll return a 1. If it's not successful, it'll return a 0. And so what we could say is that we want, if it's not successful, we need to have this whole process start all over again. So we could say something like while return val is not equal to 1, well, we could go through this whole same sequence again. But what that gets us, right, let's build and run. What that gets us is, okay, I'm going to type that R again. It gets us that same behavior. So Control-C to kill that. All right. Simply because we still have that value of R out on the input stream. Right? Let's just go ahead. When we come in here, we know then that we have that value R. I told you we have that value of R sitting out on the input stream. So what if I just say, get char, I'll call the cval for character val. What if we call the function get char? Right, get char reads one character and returns it to us. Let's take a look. So here, this is C++.com's reference. I typed in get char in the search here, and we'll take a look now. Yeah. Let's zoom that out. Zoom in, sorry. All right, so get char gets a character from standard input stream. That's where Scanf gets its characters, from the standard input stream, our keyboard, right, which is attached by default with a C program. So get char doesn't expect any arguments, right? It's got a void here in the parameter list, and it returns something of type in. Well, it returns the next character from the standard input stream, and it returns it as an integer value, right? And what I always like here, see, it tells you it expects no parameters. It gives you an example, right, of how you could use get char, right? I'd say whenever you go to this site, you pull out this code, you throw it into a C program, you run it, and understand how it works, right? But what we're going to do is we're going to take advantage of the fact that get char returns this character. Now, because it returns an int, I could make then this value an int here, or I could simply say, let's typecast this, right? So typecasting, I put the data type I want in front of this. It says, for purposes of this, treat this as a char. So it'll return it as an int, it'll reduce it to a char, right? An integer has more bits, it's just going to remove the upper order bits, which is fine because for the char, we only need the lower order 8 bits, right? And let's go ahead and run this now. So let's do a run to cursor. And let's type in our value of R here, hit the enter key. All right, so now in our program, right, we see return value 0. So scanf failed to read, it returned a value of 0. So when I say it failed to read anything and store it in choice, right? It returns the value of 0 when it fails, right? Choice has some sort of garbage in it. But now look at cval, right? This line already executed here. We can see that cval has the character R. So we've removed that from the stream, right? If I actually just go ahead and say next line, right, and then next line, well, we can see we're prompted again. And if I type a good character now, right, such as 1, it's going to go back to my main menu. Actually, sorry, it's going to come back up here. It will go back to the main menu. So I typed in a good character of 1, right? Scanf stored 1 in return val, right? We can see red val has a 1. It comes up to the while loop now. This test will be false, right? Well, that's not equal to 1, so now it will return choice, which is a 1. It'll return back to our main menu program, right? So that worked in that case then. We removed that one bad character from the stream. So we want to remove bad characters from the stream. All right. Oh, sorry. And now let's see what happens if we run this. And what happens now if I type R7? Well, what happened is it read in the R. It was a bad character. Get char removed it from the stream. The next thing sitting there was 7. So when this looped back around, it pulled in the 7. It returned a 7 back to the main program. And the main program said, when you get a 7, quit. Right? So what happened here is, see how it popped up the menu choice, but yet we didn't type anything? That's because it pulled a 7 from the stream. Right, so it displayed all that, but it looks like we didn't type anything. It didn't give us the opportunity because when scanf went to read the second time, it already had the 7 sitting out there. And let's just go through the debugger with that to see that. All right. So run the cursor. All right. We're going to now type R. R7. Let me minimize that. All right, so now we see that scanf here returned a value of 7. It couldn't read anything. If I say next line, get char will execute. So now cval has that value of R in it. We'll display the main menu. So next line, return val scanf. So notice, right, I didn't even have to go out and type anything else at the keyboard, right? Scanf went out and read that 7 that was sitting in the input stream. It put that in choice. return value is a 1. Right, so next line, that's false. It's going to return choice back to main. This will say, well, while menu choice is not equal to quit program, but 7 is, right, it would go ahead and quit our program. So what we saw is that we have other characters out on the stream. It's going to automatically pull those in. All right, let's run one more time. Well, what happens if I type RR? Right. Well, our program goes back around and recovers in a way. It actually pops up the main menu again, tells us to enter a choice, doesn't give us a chance because it pulls out that other R from the string, and it comes back around, and now it's waiting for me again, right? And if I type RRT, well, we're just going to see it scroll back around. We don't quite want that behavior for the user. Right. So let's then, when we want to clear the stream, let's go ahead and put this in the loop. The thing is getChar always returns whenever we hit the enter key press, right? In the same way, Scanf always returns whenever we hit the enter key press, meaning Scanf, right, when we type in, like when I typed in RR and hit the enter key, that enter key press is still out on the string. But what I can do is I'm going to clear the stream of all characters, right? So clear the standard input stream, clear all characters. I'm going to say while. I'm going to typecast, then getChar. While getChar, I'm going to call the function here. Typecast that back to char while that is not equal to. And my enter key press, that character should be this new line character. Just keep cycling through, removing characters. After you've done that, then I want you to go ahead and display the main menu. Then you can go ahead and try to read again. All right. All right, so run the cursor. All right, so it's waiting for me to type something. So RRT. All right, so we got that. All right, we got that original bad values are from Scanf. We can see we got then choice has garbage. It didn't read anything in. Return value has a 0, meaning this condition is going to be true. So next line. All right, so now if I just say, if I say step into, right, actually what it does is it just read all of the characters here. It removed all of those, so that while loop just fully executed. It didn't let us see everything. Well, it removed it because we didn't store it in a variable. If I stored it in a variable, we would have seen that. But next line pops up the menu, right, it waits for me to enter something good. I'm going to hit it. And, all right. So what I'd like to do is, you've seen this behavior. Let's just go ahead and store everything from getChar. But what if we said something like, all right, what if we declared our cval, so our char, our cval, and then called getChar, and then if we said, well, cval is not equal to the new line character, well, we want to do this again. All right. Just so you can see the characters being pulled in. All right, so there's my RRT. All right, so right now return value then has a value 0. Choice didn't get anything. Now if I hit next line, we'll call getChar and it should read that first R in there. Sure enough, there's our first R. Cval is not greater than, and so now we're going to then call getChar again. There's our next R, right? Cval is not equal to that. We call this again. We get our T, right? Cval is not equal to the new line. We call this again. We get our \n, our new line character, and off we go. So that's the longer way of writing it. right, of writing it like this, of saying, well, let's get the first character. Let's compare it to see if it's equal to the new line character or the enter key press, right? If it's not, then I need to get another character, and I just need to keep looping until I get all of those characters, right? The shortcut way of writing that is simply the first way I wrote this, is I say, I typecast this into a char. I should have typecasted it. Actually, I should have done a typecast on each one of these as well. But I can get rid of that variable declaration, right? Because I just want to throw away the bad characters. I really don't need to save them in anything. And same here. All right, if we build and run. Now, if I type RRT, right, it removes all that and simply just pops this up again, and it's waiting for my choice, right? Now, here's the other thing. If I type the R and the 7, it's going to get rid of the R and it's going to get rid of the 7. It's not smart enough to say, well, let's get rid of the R and then take a look and see if the next one's a number, right? That requires some different logic on our part. Our logic at this point is we're just saying, you know what, if I type something bad, let's just assume everything on the line is bad and remove it, and then pop up again and give them another choice, right? Which if they say 1, takes us back into fill the array with random numbers, right? Cycles back around, I can hit 7 to quit, my program quits. Right, so that's what I can do to help to recover from a scanf failure. And I could go ahead and put that code in other places as well than wherever I was using scanf. So besides there, where else were we using scanf? Well, we're using scanf here as well to get this information, right? So here, we might want to then make some sort of return value. Here I can then say, well, let's assign return val. I'm going to stick with return val. All right, let's assign that. And then we need to do the same thing. Well, that's not equal to 1. Well, we need to do a similar thing. We do it this way. Well, it's not equal to 1. I need to clear the stream. Then I need to do the same thing that I was doing outside the loop here. I need to do that same thing again, which at this point you might be thinking a do-while loop might be a better choice, right? Rather than writing this code and then this code. But now get low value. Let's see if we mess up on get low value, if this recovers. All right, so 1 is my menu choice. Low value, well, there's some characters. See, it comes back up and prompts me again to re-enter those until I get something better. 45, high value, we haven't coded in. All right, now I just gave up high and low different. That might be an issue. You might want to do something to check for that in your homework. All right, so that cleared the string. Let's go ahead and run this one more time. So what happens here if I type a 1 is a good value and then I enter a bad value, like say, well, R. So the 1 we know will prompt us to execute the code, fill the array with random values. The R then is still in the stream, so it's actually picked up by the low value, right? Which then reads that and prompts us again to end with a low value, right? So C was not necessarily made for keyboard input. I mean, there are these functions, but this doesn't seem like a very elegant way of having to do this, does it? All right, 70 quit. All right. So what I could do is, the other thing I can do is anytime I use scanf. So when Scanf is even successful here, I could still try to clear the input string to avoid any of that happening before. So Scanf was successful. Remove any other characters from standard input. All right. All I need to do is the same thing again, because actually sitting out there, even when Scanf is successful, that new line character is sitting out there. No, I need to stop this from running. If I build and run again, all right. So if I type 1R, now that cleared that R out of there for me, right? And then I could type my low value, right? And then some high value. I could quit, or I could do Control-C to end this. Right, so that recovered. Let's see what happens though if I run it and I don't type that R value. What if I just run it like I should, right? What if I do what I should as the user? So if I just go ahead and type in 1 and hit the Enter key, it still works. That's what we wanted, right? There's some extra code then going on behind the scenes in terms of checking this information, right? But now, if I do that, well, that worked then for low value. What's happening is we haven't handled this in high value yet. Right? So notice I'm kind of writing the same code over and over again. It's just one line. So there comes a time where we go, do we really want to put one line inside a function to avoid rewriting this? But so what if I then just call this clear standard input string? I don't need to pass it anything. Right? It's not going to return anything. What if all I do in here is this? Right? And now what if here, what if I just call my function clear standard input string? Right? And then I can replace this with that as well. And then in get low value, right, I can just replace that with that. And I can do that as well to recover when we get done here before we return. And then I could do something similar and get high value. Let's just test this. All right. So if I type 1 RRT, right, it took the 1, came up and said, okay, well, if I type R5, it just prompts us again to enter then a good value. So if I just type 5, it works and goes to high value. But now we know high value will fail then due to the fact that I haven't handled it there, right? So you can take a look then at how we handle this here. We had to add some of this code here, but I need to repeat enter high value, not low value. And now let's see if high value recovers. No, and I didn't declare the variable. All right, 1, give that a good value, and now high value. All right. Uh-oh, high value did not recover. What did I do there? Time to use the debugger. All right, let's step through this now and see what's happening. All right, I'm going to do a run to cursor here on low. Right. Oh, the other was still running. I need to stop that. All right, run to cursor, because I am now going to say, yes, I want to build the array with random numbers. All right, let's step in to low. Oh, let's step out of print F. Right. So next line, next line. Then I entered some good value here. And next line, next line. All right, that's going to return 4 back, your main. Now let's step into high, let's see what happens here. All right. All right, so now I didn't capture the return value. That's why we had that. I didn't make all the changes I needed to. Copy paste without thinking gets me into trouble. Now, we capture the return value here. So this was or was not true based on the garbage stored in that value. All right, so now if I build and run, all right, so if I say 1, and then low value is good, but now my high value is garbage, it prompts me again for my high value. All right, 7, garbage. We come back here, we're good to go. All right, so that's what it takes to clear the stream. You might want to try writing this with a do while loop. I wrote it with a while loop. You can see when I write it with a while loop, I have to perform these actions outside here, check the return value of scanf, and then when scanf fails, I need to perform these actions in here again, these same actions. Right? You could also see that if you wanted to, you could actually create some little function for taking care of this and call that function again. So we can break things down into several functions if we want. This is probably fine for this assignment. Right? So have a go at this. See, you should be able to then use this technique to clear the input stream. Now, a few people occasionally like to use another function that I'll mention before we quit. All right, so C++.com, I went to this function, and this is called Fflush. F in front of a function usually stands for a file operation. Right, you can see then this function takes a file stream pointer. You haven't necessarily talked about pointers yet. What it does is it should clear the stream. So it says if the given stream was open for writing or if it was open for updating, right, it's going to write any output data first. Well, we're talking about a read stream. Standard input is a stream we're reading from. Stream's a null pointer, then all such streams, so all streams are flushed, input, output. Other cases depends on the specific library implementation. So this tells you in some implementations, flushing a stream open for reading, right? That's what the standard input stream causes its input buffer to be cleared. So that's the standard input stream. But this is not portable expected behavior. But I don't like to use things that aren't portable from one operating system to another, right? It keeps the stream open. I'd prefer you don't use Fflush at this point. We haven't studied files. You don't have a really good idea of how these streams work yet. In our case, if we were to use Fflush here instead of this, we could potentially call Fflush. Right. Now, if I compile, is it happy about that? No, because I haven't given it any pointer. I can say stdin for the name of my stream. Right. Similarly here, I can get rid of this call here once I flush this. Fflush, I can give it the stream pointer here. Not happy about my comments there in main, but if I build and run, all right, so I put that in high value, so let's mess up high value. Notice this works. All right, and it still works. All right, so I said some people then use this operation. We haven't really discussed it in class. We haven't worked with files. If you do use it, be aware that this is a file pointer, right? It's a pointer to standard input. When we get to files, and after we've gone through pointers, this might make a bit more sense. For now, right, I expect this might make a little more sense with getChar. Now, you could use Scanf and read a character at a time too, right? Instead of getChar, we could just keep reading with Scanf, clearing the input string. So don't forget to add that to your program. The assignment requires it.